Okay, so now that we're going to move on to polars. Now, I'm not going to do a review of how to graph polars and everything in this unit because that would take too long in terms of like, limit-ons and loops and all that stuff. You can probably find other sources online to do that. I'm just going to show you the calculus related to this. So let's say that you have a question that says, find the tangent line to a polar curve. So let's say the polar curve is r equals, let's do 4 cosine theta. To graph this, the first thing you probably are going to want to do is draw a graph just so you know what you're dealing with here. It would look something like this. That's what 4 cosine theta would look like. So the first thing we got to do is we got to basically convert this into a, well, I mean, you don't have to. Okay, you need to convert this into an x equation and a y equation because you want to cut this into an xy plane. You got to put x's and y's in here somehow. Now, we don't need to go ahead and find what the original equation is, even though looking at this, it's a circle, you probably should be able to know in your head what the equation of this is, but regardless, you don't need to do that. Basically, what you have to do, and we're going to say tangent line at pi, or at theta equals pi over 3. You want to find, how about, yeah, we'll do the line. So, what we want to do is you want to use the two equations that we learned in pre-calc to convert polars into x and y form, although we're not going to do it all the way, I promise. If you guys remember the formula, x equals r cosine theta, and y equals r sine theta. It's all based off a triangle. You can look up an explanation online. So we're going to plug in r right here. So you're going to x equals 4 cosine theta times cosine theta. So it's going to be 4 cosine squared theta. Y, we're going to do 4 sine theta cosine theta. Next thing we're going to want to do, now that we have these is basically parametrics. This is pretending like these are t's, but instead of t's we're using theta. So for every theta, the x is going to move by 4 cosine squared theta, and this one's going to move by 4 sine theta cosine theta. So we're going to do the same thing that we did before, where we're going to take the derivative and then take the derivative and divide this one by this one. Or divide this one. You know what I mean. Put this one underneath this one. So, dx d theta here equals 8, by the power rule, 8 cosine theta times the derivative of cosine theta, which is negative sine theta. Now, I just want to point out something, that this is the same thing as 2 times 2 sine theta cosine theta, which is the same thing as sine of 2 theta, so this actually equals 2 sine of 2 theta. If you don't know how, it's because 2 sine theta cosine theta equals sine of 2 theta, and because there's a 4 in the front, it'd be times 2, so like that. Okay, now that I've explained that, it's much easier to take the derivative of this than doing product rule here, which I don't really want to do. So dy d theta equals 4 cosine of 2 theta. So then you can say that dy dx would be this divided by this. So if you don't know why, look at my last video that I just did. 4 cosine of 2 theta over negative 8 sine theta cosine theta. Obviously, this can cancel out and become a 2 on the bottom. And then this can turn into cosine of 2 theta over negative sine of 2 theta, because sine of 2 theta equals that, and you're left with negative cotangent of 2 theta. That was actually a really cool coincidence that ended up happening. So now we got, this is the derivative, dy dx, for if you were to convert this into a thing. Note that I never found the original equation. That would be a lot of work. Now what we're going to do is plug in this value to get what the slope is going to be at that point. So at theta equals pi over 3, negative cotangent of 2 theta, so it would be 2 pi over 3, which equals, one second, so that would be 2 theta over, or 2 pi over 3 is right here. The tangent for that one is negative root 3. So because it's cotangent, it would be 1 over root 3 because there's a negative there. Then to find what the points are, you would just plug this in up here. So this is the slope, so I'm going to circle that. X equals, I'm going to try to write a little smaller so I can fit this all, cosine squared theta. Then you plug in pi over 3, you get 4 cosine squared pi over 3. Cosine pi over 3 is 1/2, so that squared is 1/4. 1/4 times 4 equals 1. Y equals 2 sine of 2 theta. So pi over 3 would be 2 pi over 3, which equals root 3 over 2 times 2, which equals root 3. So this is the x point, this is the y point, this is the slope. Now we can finally make the equation y minus root 3 equals 1 over root 3. I'm not rationalizing the denominator because I don't care. X minus 1. And that right there is the tangent line on the x and y plane when theta equals pi over 3 for r equals 4 cosine theta. I do recommend before you take your test or exam on this unit that you look up polar review, how to draft polars. This is the easiest polar I could have chosen. There could have been limacons and dimples and loops and roses and all this stuff. I chose a pretty easy one, so please look into that. And yeah, that's all I want to say.